Hello, everyone. I'm Daniel, and today we're going to be talking about virtual environments. So first, a disclaimer before I begin is that the clicker doesn't work. All right. It does work. It just, I guess, backwards means forwards for some reason. Okay. So the first thing I want to mention is that I will be talking about specifically Unix virtual environments. So Windows virtual environments work more or less the same way. You can think of them in kind of the same manner that you would. It's very much still the same concept. However, the way that they the way that they achieve what they are supposed to achieve and the way that the method that they use to get to the end result is a bit different. The reason is that the Windows file system and the Windows operating system doesn't have or didn't have until very recently some of the concepts that the Unix file systems and operating systems have. So the pathway to get there is different, and it's still interesting. It's a bit more involved and slightly more complex, although you can think of sort of the black box working in the same or providing the same end result. So yeah, I won't be going into that specifically. If you're interested, you can check it out. And if you're interested, you can also use a better operating system than Windows. I guess second disclaimer is that there's a bunch of terminal output and just a bit of code in the talk. I tried to make it as large as I could so that everyone could see it. So hopefully you can. If you cannot, well, I guess you're fucked because I cannot change the slides. So just know I tried, okay? I guess with this always relevant XKCD image as a backdrop, I will talk a bit about the motivation for this talk. So I think we all use, the Python, I guess, background is very large. People use Python for a lot of different things, for embedded development, data science, web development, that's my case. And we all use virtual environments to some degree. However, I find it that it's not common that we usually go into the virtual environment to see how they actually work. We more or less work with the abstraction, and that's quite good enough for what we need to do. So I thought I would take a look inside what's a virtual environment, what it actually is, what it's made of, what all the different pieces that are inside kind of cooperate in order to isolate our packages. And that's kind of the motivation for this. I think it's like widely applicable. And although you don't necessarily need to know this, there's a lot of applications and you can infer a lot of the inner workings of how things are going to function if you kind of understand what are all the different pieces inside of these venvs. So I think to start, I will begin with the Python installs in operating systems. So this is kind of a quick overview of how regular Python installs are function in your OS and why use virtual environments in the first place. I know this is more or less widely understood at this point, but I think it's good to do a quick refresher and also to see how the install is packaged into the system, because the virtual environments will, for the most part, replicate that just in a different folder. We'll see the differences, but it kind of applies. So if you try to install a package onto your operating system, you'll see that something like this happens. The problem here is that pip is a package manager of some sort, and your operating system already has a package manager installed in which all the dependencies are handled. So you cannot really, it's not possible, or it's technically possible, but you are more or less prevented from trying to install regular OS packages into or via pip. The reason is that, well, your operating system does actually use all of these packages, and if you try to override or punch over what your operating system is doing, you will run into compatibility issues. You might actually just end up breaking your OS totally. So you're sort of prevented from doing this, right? And this also applies to projects themselves. So if you don't install anything into your project, by default, you will go into whatever package your operating system has, but of course you cannot rely on that being the same version, same thing that whatever other people you collaborate to have. So that's where the abstraction for the virtual environments sort of comes into place. So this is more or less what a virtual environment looks like from the point of view of the operating system. In my case, they are under user lib and user bin. In yours might be slightly different, but the thing still applies. So under bin, you have the binaries, and these binaries are the actual Python binaries, the runtime. They are symlinked to the respective version, and there's not just much to know there. This is the compiled interpreter. While under side packages, you have the actual packages. So you have all of your dependencies. So under user lib side packages, you have your entire dependencies. And if you go into this folder, you will see that there's no particular magic going on, and operating systems don't necessarily do anything that your package manager wouldn't do otherwise. There's just a bunch of Python files in there. And these are the ones, again, that your operating system uses to work and to function. So you're advised to not touch that too much. So now that we've seen how this works, we're going to see what the CPython venv module works and how it functions. So this is the output of what's inside a virtual environment. If you cannot see kind of all of that stuff, don't worry, because we will go into one of the different folders. We'll go into each one of the different folders one by one and see which one of those contain. But largely, there's the bin, which, as we've seen before, it's going to work in almost the same way. We have the include folder, which I'm not going to talk about specifically. It's almost legacy. It still has very minor use cases, but if you go into your projects, it's very likely that you'll find that this folder is empty. With the advent of wheels, this has become slightly outdated, so I will not go into that too much. Then you have the side packages, which again, these are the actual dependencies, and what pip does is just pull your dependencies into these side packages. And lately, you have a pyvenv.config, which is the file that indicates or works for designating that what you have inside there is actually a virtual environment. So we'll go one by one, and we'll start with side packages. This is the output of a newly created virtual environment. So this is what's just inside if you just use the CPython module to rawly create a venv. And the first thing that might be interesting to you is that you already have pip in there. This is by design. So Python, all of the Python distributions come bundled with pip. This is not connecting to the internet. This is not downloading pip from anywhere. Pip comes bundled into Python, and it gets installed into the side packages with a tool called ensure pip. So the first thing that you will already have in your virtual environment is pip itself. This is the way that we have to solve this kind of chicken and egg problem, where how are you going to install the package that install packages if you don't have the package that is able to install these packages, right? You run into this kind of cyclic logic issue. So this is how it's solved. It comes by default. And again, no internet connection, no nothing. If you just do it with your connection unplugged, you will still have pip in there. So that's one thing that's already there. And this is the output of the side packages with a bunch of packages installed. Each package themselves has its own folder and a distribution info file. This is just very much the dependencies themselves, so not that interesting to go deeper into. Then we have the bin folder. So this is the output of bin, and you see that we have a bunch of things that were not there in our OS Python install. We have a lot of different files, and we'll go over which one of those mean. I hope you can see the output kind of clearly. So we have, to sum it up, we have on one hand Python itself, which you will notice it's actually a symlink to the operating system Python. So what the CPython module does is it takes your base operating system install and it symlinks to there. One curious thing you might not have known is that when you execute Python from inside a virtual environment, you are running the same Python that you have in your operating system. So if you botch that, or if you have a custom build or whatever, that's what's going to be executed into the virtual environment also. It's exactly the same executable, it's just linked there. You also have pip. And this also might seem a bit weird. Why do we have pip here if we had it there? The reason is that this is the entry point for pip. So inside of the bin folder, you have all of the different executables in a kind of generic sense. So in order to run pip, you need to have something that actually goes into the code of pip and executes it. This is it. If you kind of take the insights of this pip file, you'll see that it's essentially just that, an entry point to the side packages pip. And this is what allows you to run pip inside of your virtual environment. On top of that, you have some random scripts. You'll notice that I have HTTPX here. And you might think, well, why is that there? That's a kind of HTTP client. Why does it have an entry under the binaries? This is because the packages that have command line utilities will put their entry points, just like pip does, will put their entry points under the binary folder. So whenever you want to use a command line utility, since you activate your virtual environment and you can execute things from there, you will have the entry point ready to be used from the CLI. So every command line utility that you have, it will have its corresponding entry point here. And finally, you have the activation scripts. So you see that we have activate CSH, fish, bash. This is what you run when you actually activate the virtual environment. We will see what that does exactly a bit later. But for now, just know that when you do activate, venv, bin activate, this is what's running. So yeah, this is the restatement of what I said before, just in case you weren't paying attention. And lastly, we're going to look into the pyvenv.config. So this file is not actually that complicated in and of itself. It's what designates that virtual environment exists. And it has some metadata about how the virtual environment is created. For example, there's the command that I used to run it there. There's the Python version. And the kind of one particular line that it has is the system side packages. You can actually instruct the virtual environments to also use your operating system base packages to work. I don't know why you would want to do this. It's highly suggested you do not to, because you kind of break the entire isolation concept of the virtual environment itself, but you can force it. And you can use it to stack your virtual environment packages on top of the base system side ones. So that's what is inside of the virtual environment. Now we're going to see how it's created. Well, creation of a virtual environment itself is quite simple, in fact. This is the CPython code. We're not going to go like super deeply into what it does because it's conceptually very simple. So there's these, you can check it for reference, and I kind of encourage you to, because it's not, again, it's not very complicated at all. What you have is, as you see, the system side packages gets created, and you have some create configuration and set of Python and set of pip. Set of pip does what you imagine it does. It just bundles, since Python bundles pip itself, like we've seen, takes the binary and the actual pip code and puts it in their respective places. So we're going to see what create configuration and set of Python do. So create configuration, you can read the docstring, is very self-explanatory, but the only thing that this does is just create the pyvenv.config file that we've seen before. So this just writes the lines and creates the very file that we've seen the contents of. And lately, set of Python, you see there's a bunch of strange lines, but if you actually look a bit deeply into it, it's not complicated at all. It takes the path of the executable. It says symlink or copy, which in many cases is going to be symlink. For example, in Windows, this is not the case. And we're going to see just now another case in which executables will be copied, but more on that later. It takes the directory name and it just links the executable and sets the correct permissions so you can actually execute it. So what do these lines of code mean? It just basically sets up the folder that we've seen. It sets up the virtual environment folder and puts inside all of the binaries that are needed to start working with it. So as you see, not anything too mysterious. You can probably hand roll your own virtual environment implementation in whatever, in not too much time, because there's nothing extra apart from setting up the tree structure and the file structure that we've seen before. So very easy to conceptualize. Well, UV is the new sort of preferred tool for working with packages nowadays. So I thought it would be a good idea to go over what they do differently and how they handle their virtual environment, since they have this philosophy of being the total package or the total solution for just package management, but also environments. So we're going to see how it works, and we're going to see that it's not that different, but it does have some minor relevant differences. from what the base CPython module does. So this is the output of a plain UV virtual environment, and at face value, or what you see here at least, it doesn't look any different. It does still have the same structures that we've seen. You have your bin, your lib, which has your site packages, and your pyvenv.config. So what's the catch? Why does UV have their own virtual environment implementation versus the CPython one? Well, the first difference, and I don't know if you can entirely see this thing, but I'm going to tell you what it is. The one thing that UV can do is that it can pull precompiled versions of Python and use them instead of using your operating system's Python binary. So we've seen before that the virtual environments by default use your OS Python binary, and it just symlinks there. UV can actually pull, so they distribute some precompiled Python binaries, and they allow you to use those instead of your OS base one. This has some advantages, so it doesn't matter which operating system you're using, you're going to be using the same actual binary, which has some advantages. It also has some cons, I guess. So virtual environments in this matter will be heavier because you have all of the actual Python code there. However, the space difference is relatively minor. These Python versions are cached into your user folder. So I don't know if you can see it, but this is under my .local file. So if you use the same Python version in different, if you use the same Python version in different projects, it will not be pulled again. It will be just linked there. Okay, so this is one. The other relevant difference is inside of the site packages. So you do have to go into the actual project, into the actual files to notice this, but you'll notice that I have drawn a red box on top of these two. And you might think, what does that mean? This is the counter for how many times this file exists in the file system. So one of the tricks that UV pulls in order to be quicker than pip is that it hard links the packages from the cache to the virtual environment. So with pip, if you download the same package over and over again and you have 10 different virtual environments, you will have the same package downloaded 10 times in different places in your file system. This is both a bit heavy in terms of space and also kind of slow in terms of downloading. Pip does have a cache, but it's not as quick as just having the file there already, obviously. So what UV does is that it downloads the files again to the UV cache, and it hard links to them inside of the virtual environment. This means that when you are installing a package that you have already downloaded with UV, you're not really doing anything. You're just telling the operating system, hey, this file also exists in this other place. It works in terms of the functioning of the program. It runs the same way, but it's again much quicker to install, no download, and again no repetition of the same thing over and over again. You have the exact same code in different packages. So this is the trick that you pulls, and part of why it's so quick. Next, we're going to see what is activating a virtual environment. So I guess we only have kind of two things to go or to finish now, which is what is activating a virtual environment and how it all ties together, and how does the Python interpreter know where your packages are and where to pull them from. Because we've seen what this is, but we haven't seen how this connects to the system Python interpreter. Like, how does that Python know where my site packages are, right? So this is the first step. And activating a virtual environment is actually pretty much nothing. It just changes your path. You can, the actual script that you see if you take a look inside of a virtual environment is a bit more verbose, but it doesn't necessarily do too many things more than this. It just prepends the binaries to your path so that your shell session knows where to look for these executables. This is what makes it so that when you activate a virtual environment and you run, for example, pip or Python, it actually goes to the bin folder, not to your system Python, and runs it from there, which is what binds it to the actual local installation. It also sets up some other environment variables regarding whether a virtual environment exists and whether it's active, and also sets the little prompt you see, .venv, right near to your shell, but that's cosmetic. The actual implementation feature here is just prepending to the path, which is a very simple thing. Again, this is the last step and how it all ties together. So how does Python know where to find these side packages, and how does it all come together so that your dependencies are bounded to your local folder? Not very mysterious. I'm going to show you some screenshots, but don't feel like you necessarily have to understand them all. It's just more or less for reference if you want to follow the entire path from the C files to the higher level Python implementation in where that path is read. But first, there's this macro which sets up the pyconfig. This gets read, and the pypath config contains the program full path. And interesting, the key part here is that the Python full path is the symlink's path. So remember, inside of the binary, the target is different, but the path to get there is bounded to your virtual environment. So when the Python interpreter reads that it's been executed from a virtual environment, it will grab the path of the virtual environment's binary, not the target or not the end executable. The reason why this is relevant is that in this function that you see right here, what it does is it takes the prefixes, so it takes the locations of the side packages and it kind of adds them. Before that if it knows that you're in a virtual environment. So this is how it functions. And for an even clearer explanation than having to understand the code, you can just check the docstring for the site.py file. Maybe a bit long to read if you like following a talk, but I very much encourage you to read these 4 lines because it's very much plain text, and it explains you in like no complicated manner how it's just relative pathing. So if it finds pyvenv.config file, which is what we have seen gets created when you start a virtual environment, it just takes a relative path from there to the side packages. So if you have a kind of a sister folder, which is called side packages, goes inside there and looks for the dependencies. That's all the trick. And again, we are within the virtual environment because it has been executed from the symlink. So this is not kind of escaping that boundary. And that's how it goes first to those side packages and doesn't kind of bleed over to the system installation unless you instruct it to specifically with that pyvenv.config setting, right? So this is it. This is kind of how virtual environments work in global. I don't know how am I doing for time, because I might have more. I'm good? Like I have, can I keep going? I have more? All right, perfect. That's what I planned. So I have finished explaining virtual environments, but I have a bit more to go, or I have one interesting thing to show you regarding how this all ties together. So as I mentioned, I'm in web development, right? And when speaking about virtual environments and Docker containers with people in conferences, I usually, or just in general, forums, whatever, one common question is, well, this is the explanation for what I said before. Should I use virtual environments if I have a Docker container? This is a question that comes very often. And since it happens to me that commonly when discussing these topics just generically, I thought I would include in the presentation. So yeah, you thought you would get to ask me, but now I ask myself and I answer myself. Yeah, I hope you have other questions that are not this one. Yes, in general, it's a good idea to have to use a virtual environment inside of a Docker container. And there are reasons for that. I'm going to explain the reasons and then a bit of the why. There are also some of, or a bit of the how. There are also some kind of counterindications or exceptions to this rule, which I will go a bit after. And you're, I think at this point, sufficiently kind of capacitated to understand why or in which situations you might run into problems. So yeah, going back to the original question, is it good to use virtual environments inside Docker containers? Yes. The reason first is that the isolation of the Python interpreter from of the base, let's say Python packages from your project's packages still holds within the boundaries of a container. So you don't want the container's Python dependencies to bleed into your project's dependencies. That's how you get, I guess, shadow dependencies that you are not necessarily tracking. You might get different versions, or you just don't necessarily want to rely on the base operating system no matter what. It doesn't matter if that's your actual machine or if it's just a Docker container. The fact that it's isolated from something doesn't mean that this principle still, that it breaks. This still very much holds. So you want to keep it in mind. You're still, this is another long-winded way of saying you're still, it's still kind of a bad practice to install Python packages in your operating system. It doesn't matter if that operating system is a container. You shouldn't be doing that. So virtual environments are still kind of the way to go there. The second reason for that is that it allows you to do multi-staging, and it allows you to do multi-staging well. So this is a very simplistic Docker file, and quite frankly, Vibe coded, so don't take it at face value. What I want to show is the general idea. So you have the general concept is you want to have a building step, and then all of your different underlying production steps behind it. So in your initial stage, you want to install your packages, and then what virtual environments allow you to do is to take the entire virtual environment and slap it on top of the next stage, and that way you already have your dependencies installed. Why do you want to do this? There are many reasons, but one good example I can give you is that if you have a production build and, for example, your test suite, you can completely separate those concerns and, let's say, have your project feed from the same base branch. Let's say that I can have this building stage with all my base project dependencies, and then I can extend from that a production build, which doesn't necessarily install anything more, and I can have a testing step in which I copy over my test suite and my testing dependencies specifically. This means that your production step or your production build will not have any of the specific testing dependencies, which is good. You have a less surface area, and it will also not have the code for the test, which is just good in general. You don't necessarily want to have that. It adds size, it adds potential attack vectors, and it's a cleaner pattern overall. So you are kind of encouraged to have a build step and then the rest of whatever you're doing with the application, whether it be production, development, whatever. There are some exceptions to this, though, or let's say that you have to be a bit careful with a bunch of things. The first thing that you have to keep in mind is that it has to be the same base image. So virtual environments, you have seen that they are not meant to be decoupled from your base computer. So they kind of work as an abstraction, but only within the boundaries of what's already there. Part of the reason, as we have seen, is that there are symlinks. So if you take a virtual environment from my machine, which is OpenSUSE, and you put it in Ubuntu, it will probably just not work because the symlink to the interpreter will not be there. The name might be different. The path might be different. It will not function. We can override this, or we can sort of jump this inconvenience by using the same base image. If you use the same base operating system, you can more or less move around, and it will work. Just be aware that when you multi-stage, you are doing it from the same base image and not skipping over different operating system versions, because that's when you might actually run into trouble. The other thing is that for UV, you do need to be a bit extra careful. Again, if you've been following, you can probably understand why. So UV does this trick where the side packages are not necessarily installed there, are just hard linked there. This means that when you copy over a virtual environment, you are not actually moving the package itself. You're just moving a reference to it. You can think of it that way. So if you try to, so what I've done here in the output you have here, I haven't shown you the entire Docker file because it's very verbose, and it just doesn't fit into what I can show in our presentation, but I can show it to you later. You'll have to take my word for what I'm doing here, which is I'm installing some packages with UV, and then I'm naively copying over the virtual environment into a different stage and letting it run. It fails. So you'll see that I have install requests, but it's not found in the production stage. The reason is that, again, what's inside of the virtual environment are hard links, and the hard links are linked to the UV cache. If you don't move over the cache, the reference to the actual file is lost. So if you do use UV, you need to be aware, or you need to be careful to also move the cache folder, which is where the actual reference packages are, so that you are bringing the kind of the entire file, not just the reference for it. If you do it that way, you'll see that it actually functions fine, and you can still follow the same pattern, and you don't have to don't have to worry about that. Just keep in mind that because of how virtual environments are bounded to your machine in some way or another, you might have to take these small workarounds. It's still very much worth to do it for the reasons mentioned before. You can decouple build stages from run step stages. You can also do without your like this pattern also allows you to do without your install time toolkit. So if you use, for example, Poetry, if you separate your build stage from your production stage, you don't have to actually install Poetry in your production build. You can just copy over everything, and Poetry will not be there because you don't need it anymore, and it's not used. So that's another one of the advantages that you can have. Same goes for UV, by the way. So yeah, that's it. This is the one thing I wanted to mention that kind of ties it all together and brings everything that we've seen to one concrete application or use case. And yeah, that's it. Hope you liked it.